Everybody. This is grade 4, module 1, lesson 2 problem set. And in this lesson, students will be able to recognize that a digit represents 10 times the value of what it represents in its place to the right. So we're going to work through this problem set. Number 1 says, as you did during the lesson, label and represent the product or quotient by drawing discs on the place value chart. So this lesson 2 sort of piggybacks off of lesson 1. We're just going to start working with some larger place values. Letter A shows 10 times 2 thousands is equal to some amount of thousands, which is equal to something. So the first thing I should do is go through and label my place value chart to find the certain place value that I need to be working with. So I have my ones, tens, hundreds, and here is my thousands that I'm going to be working with. And this shows that I have 2 thousands. So really the most important part of this lesson is looking at what happens when I multiply, by 10 or do 10 times some number. Well, what happens when I multiply by 10 is these non-zero digits are actually going to be moving over to the next largest place value when I multiply by 10. So rather than having 2 thousands, when I multiply them by 10, I create 2 10,000. So I move to the next largest place value, and that's the 10,000s. Okay, so 10 times 2,000 is equal to what would be 20 thousands, or 20,000, which would be 2 10,000s. 20,000, or again, could be 2 10,000s. They represent the same amount. S-A-N-D-S, thousands. Letter B says 10 times 3, and this time our unit is changing where we're looking at 10,000s. So this is my 10,000s place right here, and I'm just sort of getting that from, looking above from number 1. This was the 10,000s here. It's sort of directly in line where we have 3 of them. And again, when I multiply by 10, what happens is they move to the next largest place value, which in this case would be the 100,000s. 100,000s. Okay, so now I have 3 of these 100,000s. So 10 times 3,000s would make, I'm just kind of look at here, 10 times 3 would make 30 10,000s, and 30 10,000s is actually equal to 300,000s. Okay. C is a little bit different because I'm not multiplying by 10. In this case, I'm dividing by 10. So sort of the same thing is true, just in reverse, where this time we're starting with 4,000. So this is my ones, this is my tens, hundreds, and then this would be my thousands. And I have 4 of them. 1, 2, 3, 4. Now, I'm not multiplying by 10 to go to the next largest place value. Okay, that's not what I'm doing in this case. What happens when I divide by 10 is actually I'm moving to the next smallest place value. So that's what happens when I divide by 10. So 4,000s divided by 10 is actually equal to the same amount of hundreds. We're still looking at 4 hundreds. Oops, I'm sorry, I didn't read this right. 4,000s divided by 10 is equal to 40 hundreds divided by 10, which makes 4 100. Number 2 says solve for each expression by writing the solution in unit form and in standard form. So I'm going to take a look at this first row here where it shows 10 times 6 tens. So I'm going to take a look at this. So 10 times 6 is 60, and that would be tens, which is also equal to 6 hundreds. Because again, when we have 10 of a certain amount in a place value, we can move it over to the next largest place value, and that's what happens when we multiply by 10. So 60 tens is equal to 6 hundreds, which would look like that. 7 hundreds times 10 would be 70 hundreds. And 70 hundreds is going to be equal to 7 of the next largest place value, which is thousands. And that would be 7,000. Now, when I have 3 thousands, in this case, divided by 10, I'm moving to the next smallest place value. So 3 thousands divided by 10 would actually be 3 hundreds, would be this number here. 6 10,000s divided by 10 would be 6 and the next smallest place value, because I'm dividing by 10. Before the 10,000s is the thousands place. And that would show 6,000. And this shows 10 times 4 thousands. So 10 times 4 thousands would be 40 thousands. Or I could say 4 10 thousands. Either way, that would show this number right here, 40,000. Okay? Number 3 says solve for each expression by writing the solution in unit form and in standard form. So 4 tens, 3 ones times 10. So 4 tens, 3 ones, that would show the number 43. 4 tens would be a 4 in the tens place, and 3 ones would be a 3 in the ones place, times 10 would make 430. So probably the easier way to do this is to think about what the standard form would be first and then go back to unit form, which would be 4, 4, and it's not hundreds. Now my 4 is, I'm sorry, it's not tens. My 4 is now in the hundreds place, so this would be 4 hundreds, 3 tens. So again, when I multiply by 10, these units just hop up to the next largest place value. So ones become tens, tens become hundreds, hundreds become thousands, and so on and so on and so on. 2 hundreds, 3 tens times 10. So that would give me 2. And the next largest place value after the hundreds is the thousands. So 2 thousands. And 3 tens, again, next largest place value would be 3 hundreds. So 2 thousands, 3 hundreds would be 2,300. Okay? 7 thousands, 8 hundreds times 10. So again, multiplying by 10, that means this thousands needs to bump up to the next largest place value, and this hundreds needs to bump up to the next largest place value. So we would have 7 after the thousands is the 10,000. So 7 10,000s. And then 800s would become 8,000s. And what would that look like in standard form? I would have a 7 in my 10,000s place, an 8 in my thousands place to create 78,000. Now this time, again, we are going to the next smallest place value because now we're dividing by 10. So 6,000s 4 10s divided by 10 means I would move to the next smallest place value. So now, instead of going from ones to tens, tens to hundreds, hundreds to thousands, it's in reverse. So thousands will become hundreds, hundreds will become tens, tens will become ones. So 6,000s, if I were to divide that by 10, that would become 600s. And 4 10s would become 4 ones. So 6,000s, 4 10s, so it will become 600s, 4 ones. So 6 in the hundreds place. I don't have any tens here listed, so I still need to put that 0 in there. And 4 ones goes in the ones place to make 604. Another example where we're dividing by 10. So 4 10,000s will become 4. And again, the next smallest place value before the 10,000s place is the thousands. And 3 10s, again, when I divide by 10, I go to the next smallest place value, and that would be 3 ones. So what would this number look like? 4,000. So 4 in the thousands place. No hundreds, no tens, but I do have 3 ones to make 4,003. Number 4 says, explain how you solve 10 times 4 thousands. Use a place value chart to support your explanation. So, in this case, we're going to use this place value chart. Okay. So I'm actually going to start here with my thousands place. Just think of this as a zoomed in version of a regular place value chart where my hundreds, my tens and my ones would be over here. I'm not going to use them in this case because I am multiplying by 10. So 10 times 4 thousands. So I have 4 in my thousands place. And again, when I multiply by 10, these are grouped up and are shifted over to the next largest place value. Next largest place value after the thousands would be the 10,000s. This is the 10,000s. Okay, and again, here's 4 of them. So 4 10,000s, what does that look like? That looks like a 4 in my 10,000s place and zeros everywhere else to make 40,000. Number 5 says, explain how you solved 4 10,000s, 3 10s divided by 10. Use a place value chart to support your explanation. So again, need to use a place value chart. This time I'm probably going to show the entire thing just because I'm spanning from 10,000s to 10s. So I'll put my 10,000s here. 10,000s, thousands. This will be my hundreds, tens, and ones. All right, let's go ahead and put this that they provide us into the place value chart. So 4 10,000s means I need to show 4 here in my 10,000s place. 2, 3, 4. And 3 10s. So 1, 2, 3 10s. And in this case, I am dividing by 10. So rather than becoming or moving to the next largest place value, when I divide by 10, we shift over to the next smallest place value. So 4 10,000s, when I divide it by 10, becomes 4,000s. Same thing over here with my tens. When I divide these 3 10s by 10, they turn into 3 ones. Okay. And what does this and this look like after I've sort of done the arithmetic? Well, I have a 4 in my thousands place, nothing here in my hundreds place. I no longer have anything here in my tens place, but I do have ones, 3 ones to make 4,003. Number 6 says Jacob saved, this is probably important here, $2,000 bills, 400 bills, and 6 $10 bills to buy a car. The car costs 10 times as much as he has saved. How much does the car cost? So again, Jacob saved $2,000 bills. So what does that look like? Well, that would look like, 2,000. 2 in the thousands place would make 2,000. $400 bills would look like a 4 in the hundreds place. And 6 $10 bills would look like a 6 in the tens place to make 60. Now, the car costs 10 times as much as he has saved. So really, I kind of got to put all of this together with addition, and that would make 2,460. Okay? If the car costs 10 times as much as he has saved, so I'm multiplying by 10. And this whole lesson we've been looking at, when we multiply by 10, all of these digits here move up to the next largest place value. So this 2 in the thousands is going to become a 2 in the 10,000s place. So there will be my 10,000s, thousands, hundreds, tens, ones, and the comma would go right there. So the 2 in the thousands becomes a 2 in the 10,000s. The 4 in the hundreds becomes a 4 in the thousands. The 6 in the tens becomes a 6 in the hundreds. This 0 ones becomes 0 tens, and there's 0 ones. So how much does the car cost? Well, this number right here, the car costs, we would read this number as 24,600, and we'll put that dollar sign there to show dollars. Number 7 says, last year, the apple orchard experienced a drought and did not produce as many apples. Okay? Not produce as many apples. But this year, the apple orchard produced 45,000 Granny Smith apples and 900 Red Delicious apples, which is 10 times the amount of apples as last year. How many apples did the orchard produce last year? Okay? So what we need to keep in mind here is these 2 years. Last year, not so good. Okay? There was a drought, and it did not produce as many apples. What they're trying to tell you is that you need to divide, because when we divide, things get smaller. Okay? This year, the apple orchard produced 45,000 Granny Smith apples and 900 Red Delicious apples, which is 10 times as much as last year. So last year was not great. This year is clearly much better. So we're going to take the Granny Smith apples, and it tells us that there were 45,000 of them this year. But to get to last year, that's just what this arrow is going to show, I'm not going to multiply by 10. I'm actually going to divide by 10. This year was better than last year. So what happens is all of these digits shift down to the next smallest place value. So we sort of remove one of the zeros. The 4 from the 10,000s becomes a 4 in the thousands. The 5 in the thousands becomes a 5 in the hundreds. And we just have 0 tens and 0 ones. Same thing with the Red Delicious apples. $900. And again, to go to the year prior, last year, I need to divide by 10. So again, all that happens is these digits move to the next smallest place value. 9 in the hundreds becomes a 9 in the tens, and we need a 0 there as our placeholder in our ones. So how many apples did the orchard produce last year? We produced 4,500 Granny Smith apples and 900 Red Delicious apples during the bad year. Number 8 has 2 parts. Planet Ruba has a population of 1 million aliens. Planet Zamba has 100,000 aliens. How many more aliens does planet Ruma have than planet Zamba? So again, we're really just looking at comparing Ruma's, I'm sorry, not Ruma, there's a B there, so that should be Ruba, which would be 1 million, which looks like this. Okay, we have a 1 in the millions place, and planet Zamba has 100,000. Okay, if you notice, it's 1 less 0. Here we have 1, 2, 3, 4, 5 zeros in 100,000, and 1, 2, 3, 4, 5, 6 zeros in a million. So we could say that if we were to take Zamba's amount, which is 10,000, or I'm sorry, not 10,000, 100,000, and multiply it by 10, that will give us 1 million, which is Ruba's amount, okay? Usually when we see this phrase in a word problem, how many more, that means that we need to subtract. So how do we get from 100,000 up to a million? Well, we would need to add 900,000 to turn into a million, because 100,000 plus 900,000 is going to give us that million. 0, 0, 0, 0, 0. 1 plus 9 is 10, which bumps my 1 over into the millions place. So how many more aliens? I mean, I could have done this the other way, where I do 1 million minus 100,000. 0, 0, 0, 0, 0. And then I would just have to sort of think of this as 10 minus 1. I could, regroup it if I really wanted to. But this is where I would need to think that 1 million is the same as 10 100,000s, which would give me the number 9 to make 900,000. So I could say that it either has 10 times the amount, Ruba has 10 times the amount of aliens than Zamba has, or it has 900,000 more aliens than Zamba. It says, write a sentence to compare the populations for each planet using the word 10 times as many. And I sort of already talked through that here in letter A. So really it just becomes, how do I turn a million? How does a million become 100,000, or how does 100,000 become a million? Okay, so I could say 1 million is, and here's that phrase, 10 times as much as 100,000. Again, when I multiply by 10, and I were to take my 1 in the hundreds thousands place, and I were to multiply it by 10, I would be hopping over to the millions place. And again, I could show that with the place value chart, just, super zoomed in, where this is my, I'll just put HT for 100,000s, and this is my M for millions, and I have 100,000, and when I multiply it by 10, it turns into 1 million.